Good morning, ladies and gentlemen. As our effort for an effective collaboration with other criminology deans and faculty members, one of those that I earnestly ask for his support is our speaker today. He is Dr. Alfie P. Sarmiento, the Assistant Dean of CCGE of Angeles University Foundation and the current PCAP Region 3 Director. He finished his BS Criminology at University of Luzon. And when he took the licensure examination way back 1999, he landed as number 5 nationwide. He also finished his Master of Science in Criminology at University of Baguio and Doctor of Philosophy in Criminology at the Philippine College of Criminology. Aside from his educational qualification, he worked as a former instructor of Institute of Metro Dagupan College and University of the Cordilleras, where he became my teacher for, if I'm not mistaken, about 2 or 3 subjects. He also had a teaching experience at Data Center College of the Philippines, Lawag. At present, as I told you a while back, he is the Assistant Dean of CCGE of Angeles University Foundation. For the information of everyone, the Angeles University Foundation has the only criminology who attained the Center of Excellence in the whole Region 3 out of more than 60 criminology schools. And as I told you again a while back, he is also the current director of PCAP, or the Professional Criminologists Association of the Philippines, Region 3, where under his leadership, Region 3 had successfully conducted 4 oath takings for new criminologists. I again repeat that all of the discussions that will be posted today, June 16, 2020, were just extracted from his YouTube channel, which he voluntarily surrendered to us. So please subscribe also to his YouTube channel under his name, because we have the same purpose, and that is to upgrade the quality of education, the criminology education, especially here in Region 3. So again, please welcome our speaker, Dr. Alfie P. Sarmiento. Thank you.
Okay guys, welcome to our lesson on personal identification techniques. This time we'll be having online lecture amidst the COVID-19 pandemic, and we are all required to do community quarantine. So let us cooperate with the national government and our local government in the crisis situation that we are facing right now. So nonetheless, we're going to continue with our lesson using the learning management system, famously known as the AUF My Class, powered by Canvas. Okay, so today is March 16, and I'll be recording my lecture, and our topic will be more on the NCIC classification system. Okay, before anything else, of course, I am your professor, Alfie. I'm a registered criminologist and your assistant dean, a lifetime member of the Asian Criminological Society, and the current pickup regional director of Region 3. And I am also one of the founding director of the Fingerprint Identification Society of the Philippines. Okay, so let's proceed with our lesson for today. Let's review a little about the core competencies of this subject. The subject follows the resolution number 1 issued by the Professional Regulatory Board of Criminology, and this is the issuance and promulgation of new tables of specification of the subjects for the board licensure examination for criminologists, short for BLEC or the BLEC. The PRC identified 5 major topics or course outcome in this particular subject. But for this series, going to focus on the number 4 topic or course outcome, which is to classify fingerprint patterns based on Henry's classification system. Okay. Here is the AUF course learning outcome, and primarily we'll be focusing on number 7, which is classify, sort, file, and retrieve fingerprint records. So you can see this in your course syllabus for the subject personal identification techniques. Okay, so you can check also additional references stated in your course syllabi. We are now on the 13th week of our course content, and here we are to complete the topic on fingerprint record classification system using the Henry, Galton, NCIC, and the AFIS program. We also have the systematic application of Henry classification formula and its rules, looking into the 6 divisions of the Henry classification system. We have to discuss also additional rules on mutilated or amputated fingers, same with missing fingers or badly damaged fingers whose friction skin are either mutilated or infected by certain skin diseases. And later on this module, we are going to discuss the basic steps in NCIC coding system and the AFIS coding system. Okay, so I have a topics for this session. We have already discussed the core competencies provided by the PRC, and this is already incorporated in your course syllabus. And of course, we have continuously reviewed the terminologies provided in your SWIG-FAST glossary, okay, the Scientific Working Group on Friction Ridge Analysis, Study, and Technology. And of course, we have to review again the various fingerprint characteristics for level 1 detail, level 2, and level 3 details. And of course, we are done with our topic on Henry classification formula. We have discussed all the rules under primary, secondary, subsecondary, major, final, and key classification. This time, we are going to focus on the NCIC, the AFIS, and the Galton classification system. So check these materials after watching this lecture video. Okay, so let's proceed with our topic, the NCIC, AFIS, and Galton classification system. So let's start with the NCIC. You can go over chapter 5 of your fingerprint source book, same with your FBI training manual on fingerprint identification, and find the topic NCIC. By the way, what does NCIC stands for, and what is NCIC? NCIC stands for National Crime Information Center. In 1965, the Federal Bureau of Investigation recognized the country's need for a centralized electronic criminal database. Within 2 years, the National Crime Information Center was born, connecting 15 metropolitan and state computers with the FBI's NCIC central computer. By 1971, all states and District of Columbia were connected to NCIC. The NCIC is made up of millions of records that have been sorted into separate databases. Criminal justice agencies can search these databases for information. One part of the NCIC database is the NCIC fingerprint classification. The alphanumeric classification system is pattern specific to each individual finger, and unlike the Henry classification system, does not involve the combination of fingers. Like Henry's system, however, NCIC classification can assist only in eliminating or narrowing the search of records for potential suspect. The NCIC system consists of 20 characters code in which each finger, beginning with the right thumb and ending with the left little finger, and this is represented by two characters. For example, if a person with all plain arches except dented arches in the index fingers would have an NCIC classification code of A double T A A double T A, and A. So to explain further the NCIC classification system, we have to consider the following. So the fingerprint classification field is coded using data from all records. The following rules. Number one, the fingerprint class is furnished on two lines. The first line represents the fingerprint classification of the right hand. The second line represents the left hand. And the fingerprint classification field should be coded using information from the least line as positions 1 through 10 and the second line as positions 11 through 20. The pattern class is furnished 1, 2, or 3 lines. The entire first line information should be used in positions 1 through 20 of the field classification field. When both classifications are available, then the fingerprint class for fingerprint coding should be used. Okay, so this will be the representation of each finger. For the right thumb, of course, we'll be using black 1 and 2. For the right index, we'll be using black 3 and 4. For the right little finger, we have to use black 9 and 10, and so on and so forth. Okay, so this is an example of an NCIC fingerprint code. You can see there 52, okay, then followed by DM, followed by 0375 14 69 TT AA 15 and XO. So what does this code represents? Of course, based on this blocking system, the first two numeric code represents the right thumb, black 1 and black 2. That would be 5 and 2. And for the right index, we have to use black 3 and black 4, and this will be represented by D and M. Okay, so basically this is a combination of an alpha and numeric codes. So this will be our lesson for today: how to convert the numerous data we have gathered using the Henry rules and substituting the Henry formula with the NCIC coding system. Let's go to the next slide. The NCIC formula for this given problem or given fingerprint record would be this written on the upper portion of the card. And you can see here numerous symbols such as PO, PI, PM, DO, another DO, SR, then we have PM, and we have DM, PO, and another PO. In our Henry classification formula, we have discussed there the rules on ridge counting and ridge tracing. Same rules apply when deriving the NCIC formula. For loop patterns, we are going to apply ridge counting, and for whirl patterns, we are going to use ridge tracing. You can see here the block symbols for the following pattern. We have W as shown in all fingers 1 to 10, with a little issue on finger number 6, which is a finger with complete scarring. So how would we classify this pattern later on? Will it be a plain whirl, or would it be equivalent to a plain arch, dented arch, radial loop, or an ulnar loop for that matter? Okay, so let's check on the various codes used by NCIC. Okay, so we have here the pattern on the first column, and we have here it's the subgroup in the second column, and we have here the respective codes for NCIC. Okay, let's start with the pattern arches. We have here two subgroups. We have plain arch, and we assigned double A, okay, for its NCIC code. And for tented arch, we have double as its representation. And of course, we have here the loop pattern, and we have two subgroups for this pattern. We have radial and we have ulnar. Now, how are we going to apply the NCIC rules for loop? Okay, I mentioned a while back that we'll be using ridge counting for loop. So RC here represents ridge counting. So whatever ridge count was derived after looking into the intervening ridges, we are going to add an arbitrary number of 50. For example, if you were able to count 12, then you will add 50, so that would be 62. For ulnar loop, okay, so we will put the coding by its actual ridge count. Okay, if it is less than 10, then we have to proceed with 0. For example, you have only 5 ridge counts, so you have to write that with 0, 5. If you have counted 9, so you have to write it as 0, 9. Okay, let's proceed with the whirl family. So we have 4 subgroups for the whirl family, and we have plain whirl, central packet loop whirl, double loop whirl, and the accidental whirl. Okay, so again, for whirl, we are going to apply ridge tracing like what we did in the Henry classification system, but this time the plain whirl will be coded P, unlike in the Henry system we code it with W. Okay, so and then for central packet loop whirl we code it with C, and for the double loop we code it with small d, and for accidental we code it with X. So you notice that the codes here are followed by whatever ridge trace was seen after the procedure of ridge tracing. And we still remember our rules on ridge tracing. We provide definite value of I, M, and O, which stands for inner, meeting, and outer. Let's have a short review of what is ridge tracing. Okay, tracings are applied for whirl, and basically what do we do when we trace? We trace from left delta to the right delta. We always start from the left, going to the extreme right delta if there are more than 2 delta. Okay, number 2, we have to trace from farthest left delta to a point opposite to the furthest right. Okay, drop down at the ending ridges. So if there are ending ridges, then we have to drop and go down to the next ridge. And if it is followed by a bifurcation, we are to choose the lower fork and stop at the point opposite to the right delta. Okay, when you reach that point near the location of the right delta, you have to stop and you have to start making an imaginary line going to the location of the right delta and start the counting. If there are 3 or more ridges inside the right delta, then the tracing will be inner. Okay, and if there are 3 or more ridges outside the right delta, the tracing will be outer or O. If there are 1 or 2 ridges either inside or outside the right delta, or if the tracing stops on the right delta itself, the tracing would be meeting. Okay, it's not necessary to count more than 3 ridges. Do not count delta or the tracing ridge. Okay, just count the intervening ridges. Okay, so these are the usual rules whenever we do word tracings. Now, let's have some few examples here. So you have seen this in the previous lessons when we were discussing the Henry classification formula. Okay, so we start from the left delta going to the right delta. Okay, so let's start with the first one. Okay, so that's the left delta. We have to make a trace. Then we have stop at that particular areas. We are already adjacent to the right delta, so you have to draw an imaginary line, okay, and to start counting. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 intervening ridges, so that's more than 3, and the ridges are above the right delta, so that is an inner tracing. Okay, so let's move on to the next example. Okay, this is your left delta, this is your right delta. Then since there is an abrupt ending ridge here, we have to go down following the type line, and as we move on to the trace, we have encountered a bifurcation here. So as the rule says, we have to follow the lower fork, then stop here, then we have to draw an imaginary line. So you notice here that we only have 1, 2 intervening tracings, so that would be above the right delta, but since this is less than 3, then it is considered meet. Okay, and the next example will be a true meeting, wherein the tracing from the left delta to the right delta absolutely meets. And of course, the last example would be this ridge in here. Okay, so left delta, and this is your right delta. There are no ridge formation right in front of the type line, so this would be our right delta. Okay, so the trace will be there, and the trace went under the right delta, but there are only 2 intervening ridges, so we will still interpret this as meeting. Hence, if there are 3 or more intervening ridges coming from this area, then we will interpret that as out or O. Okay, so that's basically the rules on ridge tracing. Here are some other examples for ridge tracing. Then you can find there the usual rules that we apply in ridge tracing. Okay, so this is an example of inner trace, and of course here is a typical example of ridges that are abruptly ending, so we have to follow the next ridge under it until we reach the location of the right delta. So in here you have counted 1, 2, 3, so that is an example of an outer tracing. Okay, so in cases of short breaks which are not definitely ridge endings, perhaps this could be a scar, a healed injury, or a natural skin fold referring to creases, then we just ignore the gap and then proceed with the tracing. Okay, so same here, we have cases wherein we have bifurcations, we have to follow the lower ridge. Okay, so another abrupt ending ridge, same as we have discussed earlier, we have creases in there. So here are some additional learnings that you have to consider. So I have retrieved this from a research journal, and that research journal is known as the Pattern Recognitions, Volume 42, Issue number 5, and released last May of 2009. So here, this is a study conducted by Zhu and et al. Crease detection from fingerprint images and its application in elderly people. So you can find here the abstract. Conventional algorithms for fingerprint recognition are mainly based on minutia information, but it is difficult to extract minutia accurately and robustly for elderly people. Okay, so this is a study for elderly people. Just imagine your ridges due to old age are already worn out, and what you see are just the natural skin folds on older people. Okay, and one of the main reasons is that there are many creases on the fingertips of elderly people. In this paper, they have studied on the detection of creases from fingerprint images, in which we treat the creases as a special kind of texture and design an optimal filter to extract them. So they also have studied application of crease detection results to improve the performance of fingerprint recognition in elderly people, which include 2 aspects. First, it is used to remove the falsely detected minutia. Second, the creases can be treated as a novel feature for elderly people's fingerprints, which is combined with minutia features to improve the performance. Experimental results illustrate the effectiveness of the proposed method. Now, this is now the application of the science, wherein creases are considered as individual characteristics of elderly people. Okay, so here are some other research entitled Robust Crease Detection in Fingerprint Images. Same, the researchers are same people here mentioned here, and was a research sponsored by the Department of Automation in Tsinghua University, Beijing, China. Okay, so you can see here the various creases seen on elderly people, and using automation, using algorithm softwares, You can see here the plotting of red points that denotes perhaps the minutia locations and the exact location of the creases. This is what you usually do if you focus or try to be an expert in ridge analysis. Okay, so I do hope that one of you here or some of you here will be interested in this particular kind of job. Okay, so again, here are some other examples. In ridge tracing, we use the symbol P for plane world and then followed by its tracing. That's why we have here PO. P stands for plane world and then O is for the tracing, which is outer. Okay, so other examples. This is meeting tracing. Okay, and here a fingerprint or ridge analyst here provided two classifications, either a PI or a PM. Okay, I stands for inner and stands for M stands for meeting. Just do your individual tracing later on, then decide whether it is an inner tracing or a meeting trace. So here amidst COVID-19, so this fingerprint pattern remind us to smile even if we are experiencing a lot of problem due to the community quarantine and restriction of travel of people. So guys, just smile while watching this lecture video. Okay, so here is another example of tracing, and this is an example of outer. So by the way, this is a central packet loop world. Okay, so followed by another. This is a central packet loop world with an inner tracing. Okay, so look at that. Okay, so there are more than 3 intervening ridges there. Okay, so CI, so we have that CI, and we have DI. D stands for double loop, and inner. Okay, so another double loop, then this is outer. Okay, so tracing here, the tracing will be starting here going to this area. So there are more than 4 intervening ridges or more than 3. So this is outer. Okay, so next would be another double loop word, and this is still out. Another double loop, and this is inner. Okay, so double loop, and this is an example of meeting. Okay, so another double loop. Okay, so this is another type of word, and this is classified as accidental word, and this is the symbol X and followed by its tracing, which is inner. Okay, another inner, and this is an example of an accidental word with meeting tracing. Okay, so there you are with our review on ridge tracing the word. Okay, again, let's go back to this table. Then we have to use a symbol of double X for missing or amputated finger. Okay, so remember that we will not use or adopt the opposite finger using its pattern like we have done with the hand reclassification formula. In cases of missing or amputated finger, we will just use the code double X. This means either amputated or a missing finger. And we will use SR for patterns that are completely scarred or mutilated. Okay, so there you are. Okay, so these are basically same rules mentioned by your reference book, fingerprint source book. So just read on the fingerprint source book, and you can find here 4 additional rules that you can use in deriving the NCIC formula. Okay, remember rule number 1 to rule number 4. Okay, so let's look into some examples of amputated fingers. I'll be using the fingerprint card of John Dillinger. Okay, you know pretty well John Dillinger. Okay, John Dillinger is already dead. Okay, he had a shootout with the FBI, and he eventually died and killed by special agents last July 22 of 1934. So in here you see an obvious alteration of his ridges because of alleged use of hydrochloric acid. A doctor who was involved in illegal drug trade have helped John Dillinger hide his identity. So after performing surgical operation to modify his facial features, he also helped John Dillinger erase some of his friction ridges. But eventually, when he was killed by agents of the FBI, it turned out that some of his ridges are still intact and could still be analyzed, and there are still significant features that could be essential for fingerprint identification. Okay, so here is another fingerprint card of John Dillinger, and you notice that in here his ridges are still intact, no damage. And look at his fingerprint classification in there. Okay, so we have here primary classification of 9/14. Then we have a secondary classification of R over U, and there is an incomplete data here for the subsecondary classification, and this is for the final classification. And we have here the key classification. You notice here that there are no major classification. Let's go back to the earlier fingerprint card. So this is the fingerprint classification provided by the fingerprint examiner after taking his post-mortem fingerprint card. Okay, so you can see here a different fingerprint classification formula. Here a major classification of O/O, primary of 32/32, and we have a secondary of W/W, and so on and so forth. Okay, so basically different from that of his ante-mortem fingerprint card or fingerprint classification. Okay, so let's move on with some few examples. Okay, so we have here the given information. Okay, so for right thumb, we have ulnar loop with a ridge count of 12. And for the index finger, we have a double loop word with outer tracing. For the right middle, we have an ulnar loop with 11 ridge count. And we have a right ring finger, a radial loop with 16 count. And we have the ulnar loop for the right little finger with 14 ridge count. Okay, that's the information provided for the right hand or the right fingers. Let's proceed with the fingers 6 to 10, which represents the left fingers. Okay, left thumb, we have ulnar loop with 27 counts. Left index is a tented arch. Left middle is amputated finger. We have a left ring finger here with an ulnar loop, and the left little finger is a central packet looper with an inner tracing. Let's apply the rules of the NCIC. Okay, so for the right thumb, we are going to use the rules, and since this is an ulnar loop, then we will just write, well, basically the ridge count. And for the right index finger, since this is a double loop word, we will use D, then followed by O, so it's DO, and so on and so forth. So this will give us an NCIC classification provided here. Okay, 12 for the right thumb, DO for the number 2 finger, 11 for the right middle finger. So since this is an ulnar loop, so it remains the same, 11. Okay, you notice here that we have 66. Okay, this is applying the rule. Okay, 16 ridge count plus the arbitrary number of 50, so that will give us 66. Okay, so pay attention with this radial loop. Okay, so radial loop here is very special. Okay, like in the Henry system, radial loop is part of the small letter group. Plain arch, the radial loop, and the tented arch, since they belong to the small population of fingerprint pattern. Then another ulnar loop, which is 14, another ulnar loop, which is 27. Okay, so you notice that if you code ulnar loop, they are basically less than 50. Then if you code a radial loop, they are always more than 50. Okay, so just remember that. Then we have here double T. This represents tented arch. Then you notice here we have applied the double X for amputated fingers. We don't adopt the opposite finger. So in case that you adopt the opposite finger, it becomes an ulnar loop. So we don't do that here in the NCIC. We only do that for Henry classification formula. Then we have the left ring. We have 17, and followed by CI for central packet with inner tracing. So this NCIC formula is much easier than the Henry classification formula. Okay,